topic of presentation is Simscape in Simulink. So in this presentation, I am going to discuss about what is Simscape, what are the key features of Simscape, extending Simulink using Simscape. Then we will perform a demonstration of simple model using Simscape, and then we will see how the Simscape simulation actually works. So first of all, what is Simscape? It is one of many toolboxes included in the Simulink, which contains tools that are required for simulation of different physical streams. It enables you to rapidly create models of physical systems within the Simulink environment only. With Simscape, you can build physical component models based on the physical connections that directly integrate with block diagrams and other modeling elements. Your models You can model systems such as electric motors, bridge rectifiers, hydraulic actuators, and refrigeration systems by simply assembling the fundamental components into the schematic. So the key features of the Simscape are it provides us a single environment for simulating multi-domain physical systems with control algorithms in the Simulink only. It features us physical modeling blocks covering more than 10 physical domains, which includes mechanical, electrical, hydraulic, thermal fluid, or even two-phase fluids. It has a MATLAB-based Simscape language. It enables text-based authoring of physical modeling components, domains, and libraries. Symbolic equations reduction and solver technology for systems of differential algebraic equations, including event handling. Simscape has specialized solver technology for real-time simulation and hardware in the loop testing. It has physical units for parameters, variables, with all units convergence handled automatically. Simscape has ability to simulate models that use blocks from the Simulink add-on products without purchasing those products. It also provides support for C code generation using Simulink Coder. So, what is difference between Simulink and Simscape? So you can see Simulink deals with the explicit equations while the Simscape deals with the implicit equations. Simulink adds relevance while we are dealing with the single body motion, multiple body motion, and most of the control algorithms. The Simscape specializes in the simulation of 1D multi-body systems, for example drivetrains, then electrical networks, hydraulic and pneumatic networks. So this example shows two models of mass spring damper system, one using the Simulink input-output blocks and another one using Simscape physical networks. The Simulink model uses signal connections, which defines how data flows from one block to another, while the Simscape model uses physical connections which permit a bidirectional flow of energy between the components. Physical connections make it possible to add further stages to the mass spring damper simply by using any copy pasting. Input-output connections require rederiving and re-implementing the equations in the Simulink model, which might be a difficult task. The initial deflection of the spring in this model is considered as 1 meter, and this is shown in the block automations for the spring and one for the integrator blocks. And these are the simulation results from both Simulink and Simscape. We can clearly notice that both of the results agree with each other and they are perfectly overlapping. Simscape has more than 10 physical models, which includes mechanical, multi-body model, electrical, electromagnetic, hydraulic, thermal liquid model, gas, gas model, moist air model, thermal model, two-phase fluid model, and isothermal liquid model. Now we will continue our by creating a Simscape model first. So for that we will use command ssc underscore new. This will create a new model in the Simscape. So this is how Simulink environment looks like, and we have opened a Simscape model in it. First we will assemble the physical network. So we will go to the library browser. In the library browser, we will go to the translation elements. In that, we will add mass to our model, then mechanical reference, translational damper, and translational spring. So now we will arrange this according to our physical model. So this is mass. Now we will adjust the block parameters. So for mass, we will add mass as 50 kgs, and in the variable we will give a beginning value of 10 meters per second. For spring, we will give spring rate of 100 Newton per meters, and for damper, the damping coefficient is 70. So this was our model. I have modified some of the blocks and gave names to them. So we have now force source, mass, spring, damper, motion sensor, and there is a pulse generator and PID controller. So now we will run this simulation, and we can see from the Simscape results. So these are the results of simulation. Demonstration, we built a model of in the Simscape environment and we simulated. But how exactly Simscape simulation works? So these are the steps. It involves first model validation, then network construction, equation construction, initial conditions, then transient initialization, and then transient solve. So in the model validation, the Simscape solver first validates the model configuration and checks your data entries from the block dialog boxes. After validating the model, the Simscape solver constructs the physical network based on these principles. Two directly connected conserving ports have the same values for all their across variables. Any true variable transferred along the physical connection line is divided among the multiple components connected by the branch. For each true variable, the sum of all its values flowing into branch points equals the sum of all its values flowing out. The third step is initial The third step is equation construction. So based on our network construction, the parameter values in the block dialog boxes and the global parameters defined by the fluid properties, the Simscape solver constructs the system of equations for the model. Now this equation contains system variables of two types, dynamic and algebraic variables. The dynamic variables are these variables whose time derivative will appear in those equations, but for the algebraic, their time derivatives will not appear in those equations. The next step is initial condition computation. So the Simscape solver computes the initial conditions only once at the beginning, that is time t is equal to 0. In the solver configuration block, the default is start simulation from steady state checkbox is not selected. So if we selected that checkbox, it will start simulation from the steady state. Transient initialization. So after computing the initial conditions or after subsequent event, a discontinuity resulting, for example, from a wall opening or from a hard stop, the Simscape solver performs transient initialization. Transient initialization will fix all the dynamic variables and solve for the algebraic variables and the derivatives of the dynamic variables. So the goal of this transient initialization is nothing but to provide a consistent set of initial conditions for the next phase, that is transient solve. So the transient solve is the last phase of the simulation. Finally, the Simscape solver will perform the transient solve of the system of the equation. In this, the continuous differential equations are integrated in time to compute all the variables as function of time. The solver continues to perform the simulation according to the results of the transient solve until the solver encounters an event such as zero crossing, floating point or discontinuity. The event may be within the physical model or elsewhere in the Simulink model. If the solver encounters an event, the solver returns to the phase of transient initialization and then back to the transient solve. So this cycle will continue until the end of simulation. So that's how the Simscape simulation works. Thank you.